So, we got our recall, skill concepts. You can do that in a simulator. You can do that on the ground. But sooner or later, the learning happens in the air. And it's expensive to rent that plane for an hour. You have a purpose when you go up. Every flight has a takeoff, a landing, and something in the middle. And there was a reason why you went up, to gain some more skill or to go somewhere. Our kids need to know the reason for why they're doing things. Our efforts need to be aligned with their purpose for doing things. And that happens in the challenge, every single project. If all the kids were here, I would say to them, raise your hand if you spent more than an hour a day on your project. And I think a lot of hands would go up, right? Okay, how many hours would you say you spent on your project?
I don't know, per week it was, in the summer it was nearing 20 hours.
Sure. And if a kid spends an hour a day on something in school, which is more than they get per subject, that's 180-something hours. That's not enough to fly the plane. So the deliberate practice we need, where we're stretching to do things that we haven't done before, has to be done outside of the school context. And that's where you come in, and that's where you might be able to save education. So, you know this. This is what you already know. This is what you don't already know. This is what you could do if someone gave you help. And every time they give you help, the circle gets bigger. Not only that circle gets bigger, but so does the area of what you could do with help. This is what the challenge is doing. This is what's not happening in regular classrooms. So how can we save the system from itself? Well, I'm going to suggest one of the ways we can do it is by metadata. Now, when I looked at this project, it looked really cool, but something jumped out at me that wasn't even in your list. Why? Because my name is a Turkish name. And I see two things there. I see St. Sophia, Hagia Sophia. This mosque is the only mosque in the world that looks like that. And you guys called it a poster. And I see flag of Turkey. And you guys called that a poster. It doesn't say Turkey in Turkish on the real flag. But anyway, what you bring to it yourself determines what you see. And the metadata is where we create the meaning. So, here's some data versus information. The fact that 100 ants died is data. The fact that they ate the cafeteria mayonnaise before they died is information. It's about causality. It's about what can we do. And so what we need to know is the who, what, where, when, and why of the learning. And we need to know what are the learning trajectories. So I'm going to put something out here to the challenge. If you guys really would like to change the world, start keeping track of the learning trajectories of the people who do your projects. Not just the time that they spend. What is the engagement that they spend? Who helps them? What are the things they go up? When they get in that plane to do their little flight, what's the reason they're going up there? Who are they working with? Who is their co-pilot? If you can keep track of that, we can then analyze that. And we can learn about what are the most powerful strategies for a given profile of learner, which can then become a laboratory for how we can boost what's going on everywhere. So that's basically, there's a lot more stuff here that I'm not going to show you because there's something I want to show you and I haven't been keeping track of the time and I try to keep my commitment, so I want to keep it as close to that 30 minutes as I can. Drew and Celia really helped out because I got stuck. I was starting to type in all the Computer Science Teacher Association standards and put them in my database because I have all the other standards in there. And I can show you that at some other time. And this morning, I was able to upload what they did, and I was able to put it in there, and I was able to code one of your projects. It was the dual fuel project, the dual of the fuel project. You all know that one, right?
They may not.
They may not. So let's find out what that project is. If we go in and we look at it, oh, you want to see something? You want to see something gnarly? This, you win for runner-up. You win for runner-up for the least number of standards. The maximum number of standards goes to English. They have 1,200 standards, K-12, out of the 3,300 there used to be. Math is the second. They come in at 496, biggest. And you come in at 173 standards as the runner-up. The people who have the least number of standards are ISTE, they have 24. Now, when you say, why are these things not getting integrated into the curriculum, I think there is a ratio about number of things, although we have to do the 1,200 English ones and the 400 math ones. But anyhow, if you ever want to see it, there are all your standards that were culled by Drew and Celia in a little bit of time with me. But what we've got here, I'll get to it this way, one way or the other. That's going to take you there. No, that's not going to take you there. Wrong one, sorry. It's a little hard because I can only see part of the screen right now and it's throwing me off. And we're using my little Verizon wireless network thing so that I can get there. All right, come on, we'll look at projects. So if we go to science, which is where this stuff starts out, what I did was I coded your project. These are all the other projects you've got in there. But if I go over to this side and say explore this project, and I might zoom out so we can see the whole screen once it lets us get there. Please be nice.
So this was a finalist this year in the challenge. They were 6th graders from Edgewood Elementary School in Edgewood, New Mexico.
So if I zoom out, we'll be able to see, I want you to be able to see the right here. It may be a little hard to see that, but here's what it is. Our project was based on the Kirkland Air Force Base fuel spill and how microbial life forms could assist in the cleanup. Our hope was that microbes would consume the contaminant, EDB, which is an anti-knocking additive that used to be in jet fuel. The EDB leaked into the ground in the 50s and 60s before it was discovered to be a carcinogen. Now the model that I've got here, we take any project, we put it through a process where the evidence equals artifact plus reflection plus validation, which then allows us to see how creativity, collaboration, research, critical thinking, and digital citizenship and technology, that's the ISTE-NETs, how those are invoked in completing the project, which allows us to then make statements about how those standards work. But we also tie into it the Common Core. And in this case, there is no Science Common Core yet, so we're using the College and Career standards. And they have a standard that says evidence-based explanations and models, and here's the ISTE-NETs, and here's the depth of knowledge, but here that no one has ever seen before, you're the first person in the world to see this other than me, is how it ties into this computer science standard, computing practice and programming, applied analysis, design, and implementation techniques to solve problems, which ties directly into that kind of thing. And if you go through all 6 of them, you'll see here's what happens when you switch to communication. And so we now see another standard down here for the academics. We see this ISTE-NETs, and we see a different standard here for the computer science standard. And if you threw enough of these in here, you'd be able to find out where are the natural overlays between this discipline in making those other disciplines come to life. But we're not caring about science in New Mexico, not for another year or 2. We only care about English, language arts, and math. So, let's show these folks how the project you did lines up with English. When we look at English, same exact project. The purpose is the same, but what happens along the way in doing that project, you're meeting this College and Career Readiness standard for key ideas and details. Write arguments focused on discipline-specific content, introduce claims about a topic for which you acknowledge and distinguish the claims from alternate or opposing claims, etc., etc. And you can't do that without the creativity and innovation standard, but when you do it, you're also doing this computer practice and programming challenge. And as you go through all 6 of them, you can see that all of the standards change because we're doing a different task. So now we're looking at production and distribution of writing when we're in communication and collaboration. The collaboration standard for the computer science comes in here, along with the communication and collaboration for the ISTE-NETs. And nicely enough, for anybody who's studied Marzano, you see there's the Marzano strategy. If you looked at TPAC, you see there's the use of technology that supports all this stuff. And if you look at Intel Teach, there's the Intel Teach rubric that would show that that was a good performance. So this is a mechanism for doing one thing and one thing only. I'll tell you what it's not a mechanism for. It's not instruction. It's not curriculum. It's not assessment. It's none of those things. It's one thing and one thing only. It's for giving an opportunity to apply what the students know and in their performance seek out evidence of their mastery. which is different. It's looking at student knowledge. That's the only piece I'm trying to do because nobody's doing it. In a nutshell, what I say is, somebody comes to me and says, I learned something. I say, great, show me what you learned. And then I say, can you tell me how you learned it? And I'm done. Yes, ma'am.
So, Ferdi, what did you come up with this program for?
Because I wrote this book.
Is it primarily going to be for analyzing information from the College Career Supercomputing Challenge? Is it a resource for school districts? What is this?
Yes, yes, and yes. So the idea is, we're in trouble. We need professional development of a different nature than we've had before. Most of the professional development we have is infected with the same virus that is our instructional strategy. So we do decontextualized instruction on kids, and then we do decontextualized professional development, and we get still no results. All right? So I wanted to come up with something that if teachers can see what kids did and how they did it, suddenly light goes on. I say, oh, I see what's needed now. I'm an educator. I can figure this out. I see it in real life now. Suddenly, I'm better able to deal with it. So this becomes a way of looking at student results through the lens of the performances. The book shows them what's all the theory behind it and how all of that works. And I realized even if I wrote the book correctly, perfectly with all the words right, and everyone read it with total comprehension, neither of which is possible, if that had happened, it still wouldn't be enough to change their practice.
Is this disc that?
No. That I wrote, I started in 2003 before I even went to the state as ed tech director and curriculum and all of that jazz. I spent 2 years there, and then I returned to the book because I didn't see that there was any time for kids to get digital learning skills, and the only way I could see to do that was to trick the teachers into doing what they should do anyway, which is these projects. So if I could do the heavy lifting for them by defining a couple of hundred projects, then that would help them. Then I ran it against the ISD nets, and then Common Core came out. And I saw Common Core coming out 2 years ago, so I started building it towards Common Core. In September, everything that you saw there, I started building that.
Well, you have two pieces coming, Next Generation Science Standards to be done
Yep.
very quickly.
That's
and
right.
Beyond that, for career technical education, they're redoing all their national
Yep.
standards.
We've got the framework to put the whole thing together because why? It's metadata. All of this is metadata.